So welcome to this session on graph theory. Here we will be discussing about planar graphs, what are regions and edges, and Euler's theorem, which connects the number of vertices, edges and regions in a graph. So let's get started. A graph is said to be planar if it can be drawn on a plane without any intersecting edges. This graph here, the edges are intersecting, but if you draw it like this, they don't intersect. So both are the same, and this is the example of a planar graph. Now, what is a region? A plane representation of a planar graph forms regions, and a region is a set of edges forming a boundary. So you can see here, this is a planar graph, and you have R1, R2, R3, R4 and R5. R5 is the outer unbounded region. So this graph has 5 regions. Now, is the given graph planar? This is not planar because no matter how you draw, 2 edges will intersect. Now we have Euler's formula, which states that V minus E plus R equal to 2, where V is the number of vertices, R is the number of regions and E is the number of edges. So using this, we look at this problem. How many edges must a planar graph have if it has 7 regions and 5 vertices? So we use the formula and illustrate. V minus E plus R equal to 2, V is 5 and R is 7. So when you substitute, you get E is 10. So this is an example of a planar graph with 5 vertices, 10 edges and 7 regions. You can see the regions R1, R2, R3, R4, R5, R6, R7. Now a connected graph, planar graph has 9 vertices having degrees 2, 2, 2, 3, 3, 3, 4, 4 and 5. How many edges and regions are there? Now we have this formula, sum of all the degrees is 2 times the number of edges. So 2 times the number of edges, when you add all the degrees you get 28. So E is 14. And now you substitute in the formula V minus E plus R equal to 2. So you get 9 minus 14 plus R equal to 2. So R equal to 7. Now we have Euler's formula, which states that a connected planar graph with n vertices and e edges has E minus n plus 2 regions. So this we prove by induction on E, where E is the number of edges. Now if E is 1, you can have one edge, one vertex or 2 vertices. If n equal to 1, then the number of regions is 2. So actually when you use the formula, you get 1 minus 1 plus 2, which is 2. So this is satisfied. If n equal to 2, you have only one region, which is the unbounded region. And if you put n equal to 2, you get 1 minus 2 plus 2, which is 1. So again this formula is satisfied. So the result is true for E equal to 1. Assume the result is true for all graphs having at most E minus 1 edges. And let G be a connected graph with E edges and R regions. Now if G is a tree, then for a tree number of edges is n minus 1 and R equal to 1. So if you substitute in the formula, R equal to, what is the formula? N minus R plus E minus n plus 2. So you get n minus 1 minus n plus 2, which is 1. So the result is true if G is a tree. If G is not a tree, then G will have a circuit. And let C be an edge in any circuit of G. If we delete C, the region enclosed by this circuit is merged in a new region. And G minus C becomes a connected graph with n vertices, E minus 1 edges and R minus 1 regions. And now you can apply induction. So R minus 1 will be E minus 1 minus n plus 2 because we are applying induction. So R equal to E minus n plus 2. So the result is true for E equal to n, and hence by induction the result is true. Now coming to a problem, a connected planar graph has 6 vertices each of degree 4. Determine the number of regions which this planar graph can form. 6 vertices of degree 4 means sum of the degrees is 24 and sum of the degrees is 2 times number of edges. So 2 times E is 24. So E is 12. So again apply Euler's formula, number of regions is E minus n plus 2, 12 minus 6 plus 2, which is 8. So that comes to the end of this lecture. We have learnt what are planar graphs, how to apply it in problem solving, and what are regions, and Euler's theorem connecting the number of vertices, edges, and regions of a graph. Thank you.